Hi, everyone, and welcome to the second episode of Humanizing Autonomy's Future of Behaviour AI series. I'm Kim Vihilya. Today, we continue our exploration into the future of behavior-based artificial intelligence, with a focus on its potential impact on the automotive and mobility industries. In our first episode, we discussed the need for a shift back to human-centric or people-first technology, and how behavior AI could be a key in unlocking this dynamic change. We then defined behavior AI as an AI system that directly interacts with humans or needs to understand human behavior for further decision-making. It considers the physical behavior of people and teaches these patterns to machines so that they are better equipped to respond with a relevant action, and not just a series of if A then B or if B then C logic. And instead, the algorithms used are designed to help the machine consider the person's context within the situation. In this 25-minute episode, we go a level deeper into the considerations business executives must face when considering new and innovative technology like behavior AI to ensure successful adoption and integration. Now, let's begin. I am pleased to introduce my colleague, Rauanq Bose, CTO and co-founder of Humanizing Autonomy. Rauanq is an award-winning engineer with an interest in human interaction with technology and its effect on future society. With several degrees from Imperial College London, his work has been showcased in New Scientist, Forbes, and Fast Company. Prior to co-founding Humanizing Autonomy, Rauanq led the R&D at Femtech Scale-Up LV, where he was involved in the creation and launch of its first product. Rauanq, welcome.
Thank you, Kim. Hi, everyone. Thanks for joining us for the second episode of our educational series on behavior AI technology. Before Kim and Pier Paolo dive into how and where the automotive industry can benefit from added layer of human context, I wanted to activate the ideation process of how a technology like this might be applied within your own product or organization. Let's start with running through the 5 considerations that all business, product, and technology owners should explore within their teams when designing, developing, and procuring machine learning software for their automotive products. Consideration 1. How is the AI built? Does it run on a black box model or a white box architecture? For consistency, when we talk about running on a black box model, we mean that although you know the input and output of the technology, you won't know how the technology actually makes that decision or what leads to that output. A white box architecture means you can trust the data and insights provided because you can track how and why an algorithm has come to that specific conclusion. Behavior AI can not only detect that it is a person, but also understand the context of what the person is doing. In this example, crossing the street, so that the system can better respond to this specific situation. With increasing demands on transparency and pressure around liability and compliance reports, you may be asked more and more to provide details on what happens around flagged incidents. In that case, white box architecture will be more accepted and trusted. Consideration 2. How is the logic behind the automated triggers designed? Understanding what automated triggers are based on is an important factor in how planning teams will ultimately create decision-making chains. Knowing whether a trigger is based on intent or understanding what the person is doing or about to do versus if it is simply responding to a series of physics-based assumptions could impact the number of alerts sent, the gravity of the response required, and the relevance of the warning. As a quick example, imagine a pedestrian standing at the edge of the pavement. If an automated technology is using physics-based models, it will only look at how far this person is from the vehicle and what their current heading is and base their actions on those inputs. So if that person is less than 3 meters away, or if their current velocity and acceleration suggests they may come near the path of the vehicle, the system could send the driver a potentially false alert to slow down. With a layer of human context and more complex measurements around the physical state and human intentions, understood through the analysis of body language in that context, the machine knows its pedestrian has no intent to cross and so would correctly not send an alert to the driver. Consideration 3. Is it ethical? With any technology consuming so much information about people and their behavior, as developers, producers, and procurers of technology, we have to make sure we know what information and data has been collected, how the machine is using, storing, and moving all that information, and how we prevent that data from being indirectly used or misused in the future. This is a really important consideration, given that the number of cameras are growing across cities and on devices we use daily, such as smartphones, computers, and home appliances. Since behavior-based AI relies on seeing and interpreting human behavior to understand and respond to people, and requires image data or feed processing to provide that insight, it is doubly critical that behavior AI software is designed ethically, so that human understanding is based solely on the person's abstracted, observable behavior, rather than anything to do with their identity. Consideration 4. Is a technology human-centric? As Maya shared in our first episode, human-centric technology is technology developed and designed with people in mind from the beginning. The more we prioritize people and their experiences and interaction with automated machines, the more we can develop technology that is intuitive, pleasant, and importantly, robust and long-lasting. Consideration 5. Is it easy to integrate, use, and scale? This consideration is not really just for behavior AI, but I'd like to end with this one, as even if you have the most exciting, ambitious technologies out there, it is not useful or beneficial if we cannot easily access it. This includes understanding which chipsets, cloud platforms, and automotive systems the software is compatible with. So these are the core considerations we challenge anyone considering behavior-based AI to look into. In the last few minutes of my talk, I'd like to give a few examples of how our team at Humanising Autonomy have developed a top-line behavior AI architecture. The customer system provides the system input layer, and it's also ultimately where the decision-making engine lives. If we can go to the next slide. Our modular behavior AI software helps the customer stack make better decisions with improved perception. The benefits of said modularity are that it is rapidly tunable to new environments and applications with a small amount of new data. It is flexible and adaptable to existing customer stacks. And the white box approach is compliant with functional safety certification. Our model is built on top of physics models that are based on changes in position, velocity, and acceleration. However, our models help overcome some of the limitations of a pure physics-based model, while being much more interpretable than an end-to-end neural network. This is done by feeding these models with key human behavioral information to help automated systems understand and react to people better and improve the experience for drivers, passengers, and pedestrians. Here you can see an example of a real ADAS application, which also shows how Humanising Autonomy can add further benefit to ADAS products on the cloud for post-event analysis. Finally, here are a few use cases we've had with our behavior AI platform. The first is an ADAS warning system with blind spot information systems, or BSIS compliance. Here, we've integrated into a new generation of eMirror that uses a multi-camera and multi-display system to enhance eMirror driver experience. Another is a retail dashcam product in which we are working with Nextbase on enhancing the ADAS perception in the next generation of the Nextbase IQ product line. Here, we're equipping them with edge and cloud outputs such as distance and velocity estimation, vehicle and VRU collision warnings, and parking mode alert. You can imagine that it's extremely important to have fine-grained behavioral analysis to provide accurate and useful outputs for these automotive use cases today. As you can see, there's a lot of activity that's already happening with behavior-based artificial intelligence. And as the perception markets evolve, behavior is emerging as one of the keys to unlocking the next level of planning and decision-making. I hope you're all as excited about it as we are. And with that, I pass it back to Kim and to Pier Paolo. Thank you very much for your time.
Thank you, Rauanq. I'd like to now introduce Pier Paolo Porta. Pierpa is one of the founding associates and board member of VisLab, an Italian company working on computer vision and environmental perception for vehicular applications. As the marketing director for Ambarella, he's directly responsible for the Automotive European business unit and for stereo vision related products. His background is on autonomous driving and ADAS and is focused on stereo vision, sensor fusion, traffic sign recognition, and autonomous vehicles architecture. He's taken part in DARPA grant challenges, participated in the VIAC and PROUD projects, and has authored publications in international scientific journals. Pierpa, welcome.
Thank you. Thank you very much, Kim, for the kind introduction, and thank you, Rauanq, for the presentation before. It's really a pleasure to be here together and have this chat on behavioral AI.
Absolutely, and it's good to record some of our chats as well. So thanks again for joining us today. So Rauanq's just given us a bit more context to behavior AI as a technology. I'd like to start our conversation with setting the scene of where we are in the automotive industry today when it comes to AI technology adoption. So having worked with clients from autonomous driving to ADAS, can you share some insight on where the industry is today?
Yeah, so I mean, when it comes to AI, that's really a major trend, right? I mean, it's not a secret for everyone, for anyone. I mean, nowadays you can find AI even in your washing machine, most likely, or in a fridge. So in autonomous driving domain, it's quite likely that you can find it pretty much everywhere, right? And when I say everywhere, I mean starting from the three main layers that you can find, right? The perception, the fusion and decision, if you want, and then the actuation, planning. Well, the planning and then the actuation. Actually, the perception is let's say, is the more natural field for AI, right? It's where everything, I would say, started, because of course, with AI, you can enhance a lot, at least some particular part of the perception. Recognition of objects, for example, everything started pretty much there, and it's, you know, it boosted a lot the performance. Nowadays you can find also AI in fusion architectures and in the planning as well. So basically all the three blocks, right, perception, fusion, and then planning, all the three blocks are basically using AI to find, if not the main mode, alternatives modes, or at least to enhance the performance, or to find, sometimes even just to find candidates, right, that can be validated with another methodology. But it's really widespread, of course.
Yeah, thank you. That's a really good top-level view of the industry. So you mentioned previously that we're at a stage where there's a lot of focus on perception, which includes vision, recognition, behavior. Ultimately, can you describe some of the steps that we're preparing for as an ecosystem? After we tackle perception and move on to decision and actioning, what does that mean for the planners team versus the technical team?
Yeah, so the planning and perception, well, let's consider in this case fusion and perception as a kind of rule block, right? It's the two blocks that are providing a description of the world, a description of the world on which the planner is basically planning on. So the planner takes that information to plan the next move, to plan the trajectory, to plan the route, to plan whatever, right? But needs a description of the world that is given by the perception and the fusion, that includes also tracking and so on, that helps understand and building a kind of world model, right? And the interaction between these two blocks is it's a really tight cooperation, because the output of the first block is the input of the other. So they really need to work very closely together. And when it comes to behavioral AI, in my opinion, this is a very good additional information that can be passed to the planner, right? Because of course, in the fusion domain, there are techniques, right, that can help, let's say, can help predicting where an object might be in the future. But of course, maybe those information are based only on some other inputs, like the previous direction, the previous velocity, previous speed, and whatever. And with behavioral AI, you add something more. You add an additional bit of information, right, that can help making everything more reliable. And this is really crucial for the planner to plan and to find the next trajectory. So definitely, it's very, very important, this let's say, this additional information. And the planner, and let's say, and it's also very important, the defining the communication between the two blocks, so that basically the planner can take advantage of this. of this additional bit of information that is produced in the first step. So definitely it's something very, very impactful in my opinion.
That was helpful to mentally plot out a roadmap as you were describing the blocks. If we move to an organizational level, can we talk a little bit about the product development and how new AI technology is fitting into the entire life cycle of a product? What are the critical points during that life cycle that team leaders need to be aware of when deciding to adopt, integrate a new AI technology?
Yeah, as you were talking, I was thinking actually of two different spots. One is actually more in my domain. Another one is something that is more related to my history. Let me explain a little bit more. So the first is that I would like to mention is data availability. So when it comes to AI, right, you need to have data. That's the point. And sometimes it happens that I come from an R&D domain, right? Mainly, my background has been, I've been growing into an R&D domain. So where you have basically, you start with your imagination, right? To explore all the different possibilities and to try to find a solution to a problem, because usually there is no solution to that problem. So you need to find the solution. And so you start exploring, and sometimes you lose a little bit the contact with the reality, right? And data availability is your contact with the reality, meaning that you can think about something, about a network maybe that can have as input a lot of different sensor or strange input and so on. But then if you don't have the data, either you are able to build the data yourself, and that's fine, or you need to make sure that you can find the data somewhere to train your network, right? And if you need multiple data, so you need to have all these databases connected together and synchronized together, because that is the basically the key for training your network. So this is my first point, the data availability. And of course, that is something that depends on who you are. I mean, if you are, let's say, big enough to be able to build your own database, that's fine. Then you can, let's say, you can use your imagination, I would say. If you need to rely on someone else, then you need to make sure that you can find the data available somewhere. That's the first point. Second point is validation. So I'm talking now about basically the head and the tail. So the head is the data availability. So before starting, think about if you have everything that you need, right, before starting. And the tail is once you have finished, okay, then you need to validate. So also how to validate what you have been developing, right? And that part is very, very important as well, because it's crucial for the product. I mean, to turn something into a product. So that's also another part that I would say it's really. I mean, I would name between the 2 points that I'm usually taking more. I'm putting my attention, let's say, more heavily.
No, I know I was thinking as you were speaking that I could dedicate an entire session just on the head and tail, but of course, I'll focus. So behavior-based artificial intelligence, okay, that's fairly new. Most of the players, including, most of the pioneer players in the space, including yourself, they're setting the groundwork for this to be integrated and scaled more easily in the future. So some of the more interesting case studies and full-scale deployments aren't available yet because they're deployed in early 2023. So instead, I'd like to ask you for any case studies that maybe you've worked on in the past that where you think behavior AI could have taken the results in a different way. I know it's a cheating question, but maybe you can share some insight.
Sure. I actually want to mention one of the things that you mentioned in my introduction, the VIAC project. That is basically, it's an acronym that stands for VisLab Intercontinental Autonomous Challenge. So we've been driving from Italy to China in autonomous mode, from Parma to Shanghai, back in 2010. So 13,000 kilometers in 3 months of driving. it's been huge experience. I mean, from all the aspects, from let's say, from a personal standpoint, from a technical standpoint. I mean, really a huge experience. And that was, I mean, 2010 was, if you think about what was happening in those years, Google just started the self-driving program back in 2010. So, I mean, that was fairly at the beginning, right, of the wave of popularity of autonomous driving. Anyway, as we were driving, right, from Italy to China, we were driving in a kind of leader-follower application, because actually there was no map at that time available. If you were searching on Google, if you were typing Shanghai on Google, right, and find the route from Parma to Shanghai, and Google was saying there is no route. Because basically at that time, there was no available map, public maps for Russia, China, and maybe Kazakhstan as well. Anyway, at least for Russia and China, I'm sure. So we couldn't actually leverage a map, right? A topological map. And so what we did is basically find, develop a leader-follower application with a van that was driven by a human driver, and then an autonomous van that was following the leader, that was basically sending kind of GPS waypoints, right? But it was an intelligent following. Of course, if there was something cutting in the middle, the following van was not just bumping right into this vehicle or whatever that was cutting in. It was intelligently managing the situation. Like if I'm telling you, well, let's go to a restaurant, each one with its own car, that follow me, right? Same thing, right? And I'm thinking that having behavioral AI in this kind of application might have been very helpful, because especially in urban environment, we could have, for example, managed a longer distance between the two vans, or maybe let's say handling more challenging situation, right? Or sometimes it happens that you have a corner case that you cannot handle. With behavioral AI, I'm sure that we could have covered more corner cases in this regard. And that's one thing that I remember from, let's say, from the past, right? That definitely could have been very, very interesting, right? With the AI. At that time, there was even no CNN. I mean, it was traditional machine vision, so quite old school. If I think about something today, something now, well, I would say, Rauanq mentioned one use case, right? That you have is the in-ear for trucks. I think that one is very, very important, because the truck is fairly big, right? And might take some time to stop. And especially in urban environment, right? The blind spots for a truck driver are significant. So having an help that can foresee what is going to happen. So even taking some kind of playing a little bit in advance, right? If not doing the actuation, maybe just warning the driver with a significant amount of time in advance, that would be already very, very helpful. So that, for me, another significant point. Yeah, I would say these two might be interesting. Yeah.
Yeah, I find that super interesting. I was imagining the cargo running from on so many levels from one
yeah.
Listen, I mean, I think there's an obvious gap that behavior AI it really does fill. And I'm excited to see some of these case studies in the coming future. That brings me to my next question, and probably my last question, one of my last questions. Although we're primarily covering opportunities for the automotive and ADAS sectors, I know there are some AV experts and participants here today, and I just wanted to ask if there's anything that the L2 community is developing that the L4 community can use and benefit from, So what's happening today that could maybe help bridge the gap between these two communities? that have in the past, from my understanding, have been a little bit separate.
Yes. Well, in general, the modules that you develop for the perception, at least for the perception module you develop for L2 are, I would say, either the same or very, very similar to the one that you are using on L4, right? And then it depends on how do you use that information, right? And how do you structure your, let's say, your functional safety and everything else around, right? That makes the difference between L4 and L2. Of course, for an L4 driving, you need more modules because you need to handle all the possible use cases. So you really need to cover everything, right? But let's say the concept is very, very similar. I would add also that up to some time ago, it was, let's say, the usual approach was shoot straight for L4 because that's where if you want to reach L4, just go for that and forget about the rest. Now it seems that given the more and more the increasing capabilities of AI, including behavioral AI, for example, and in the increasing power of the engine on which these algorithms are running, right, that are used on ADAS, it seems that also the way from the bottom up, so from L2 increasing L4 and then getting increasing L3 and then getting to L4, it might be a viable solution. So I would say it's not clear who's going to win, right? But I would not give it for granted that shooting for L4 directly is the only way. Probably there is also the other way from the bottom that is viable and looks like it's followed by many people. So,
well, that must have been very interesting for you, at least, to understand both sides of the coin. I've got time for one question, and it's very quick. What do you and every leader in this session need to see from behavior AI technology to consider it a viable must-have technology?
To me, it's reliability is the key here, because when you have, if you can count on this information, as I said before, this information can be very, very powerful, but needs to be associated to certain degrees of reliability, because then you can really leverage that information in the following steps.
Yeah, fair enough. Pier Paolo, thank you so much for your time and insight. That flew by. It was so fascinating. So there's a lot there, and if there are any questions, we'll try and capture them and send answers later. So thanks everyone for joining us today. We hope you enjoyed it. Please do subscribe to the 4-part series of Future of Behaviour AI. Episode 3 is designed to run in March 2023. We'll be focusing on other applications for behavior AI. And if you're not already connected with us, please follow Humanizing Autonomy. We're on LinkedIn and Twitter, and we also have a newsletter. If you have any questions, please email us at info@humanizingautonomy.com. So until next time, from the team at Humanizing Autonomy, thank you very much and goodbye. Have a great day.